So let's talk about graphs some more, but focus on the domain and range. So again, with these inverse functions, I'm just going to keep emphasizing this. It's about switching the input and output. And what we can remember is that domain focuses on input values and range focuses on output values. So let's look at this first graph here. We have this graph f of x. So let's first describe the domain and range. So for the domain, our x values are starting at -1 and ending at +2. And then we have solid dots there, so we're including those endpoints. So the domain is going from -1 to +2 using square brackets. And then for range, it looks like it's starting at about 1/2 and then going until +4. So we have y values from 1/2 up to 4, including those endpoints. So now let's graph our inverse function, which we can do that, again, either by thinking about the reflection, or what I'm going to do is just think about the coordinates. So like I have this -1, +1/2. I'm just going to switch those. So +1/2, -1. So we have a point right there. 0, 1 means we have 1, 0. 1, +2 means we have +2, 1. And 2, +4 means we have +4, 2. So just switching those x and y coordinates, we can make a graph of our inverse function. Now, for the domain, we're going to see is it's starting at +1/2 and then goes until +4. So the domain for my inverse function starts at 1/2 and goes to 4, and the range starts at -1 and goes to +2. So what we can see here is just like how we're switching the input and output values for the coordinates for how our function operates, same thing's happening with domain and range, where domain is about the input for our original function that would relate to the output, which is the range of our inverse function. And the range of our original function, which is all about the outputs, links to the inputs of our inverse function, which is all about domain. So essentially, if you have the domain and range of your original function, and you need the domain and range of your inverse function, you just switch them. So for this example here, let's see if we can do this without graphing the inverse function. So I have the domain and range of f. So for domain, our x values are starting here at -1. And then our function is defined until we get to, that looks like +10. And we have an open circle there, so we don't want to include +10. So we have 10, and then we'll use parentheses there. Then for the range, so our y values start here at -3 and including -3, and then we go until +9, but not including +9. So -3 to +9 with a parenthesis at +9. So without graphing the inverse function, just knowing this property, I can write the domain and range by just switching them. The domain of the inverse function is going to go from -3 to +9, and the range is going to go from -1 to +10. And we would have answered that question and had complete full credit. However, just to get some more practice with graphing and just to prove that this is in fact right, let's go ahead and make a sketch of this graph. So let's see, I have the coordinate -1, -3, so that means I'll have the point -3, -1. I have 0, -2, so I'll have -2, 0. 1, 0, so 0, 1. So all I'm doing is switching my x and y coordinates. Let's see, that looks like 2, 4 just about. So let's go, or sorry, 3, 4. So we'll go 4, 3. And what else? Let's describe this endpoint. So +10, +9. So we'll go positive 9, positive 10. And that'll be an open circle. So we're going to have something like this for our inverse function. And as you can see, starts at negative 3, ends at positive 9, but not including. Range starts at negative 1, goes to positive 10, but not including positive 10. So that's the shortcut with domain and range, is you just switch them for the inverse function. So all of this wording, domain of f is the range of the inverse, range of f is domain of the inverse. So they just switch is the punchline. All right, so let's get some practice here with an actual function. So we have this function 2 minus 3x squared, and we're looking for x less than or equal to 0, because as we talked about in that video for graphing, we have a parabola here, and a full parabola is not invertible because it fails that horizontal line test, but if we restrict the domain, it'll work great. So let's actually start with graphing this, because what we can do is make a sketch of the graph, and that can give us our domain and range. Domain, actually, we can already see because we see our restriction right there with the x has to be less than or equal to 0. Typically, domain for parabolas is all real numbers, but we're saying it has to be less than or equal to 0, so we're seeing everything from negative infinity up to and including 0. Now the range is a little trickier because that's going to depend on our vertex. So if we're graphing y equals 2 minus 3x squared, and what I can even do is rearrange that a little bit, because what I'm going to do here is refresh our memories with our graph transformations. So this here's my parabola. With that negative 3, well, that tells me that the parabola opens downward. Or really what that's doing is reflecting over the x-axis. Those both accomplish the same thing. So you could think of that as reflect over x. With that 3, we're seeing a vertical stretch by 3. And with the plus 2, we're seeing a shift up by 2. So what we could do is think, so my standard parabola usually has a vertex at 0. That's not going to be affected by the reflection, it's not affected by the vertical stretch, but it does change with that shift up by 2. So my vertex is going to be at 0, 2. Now, I'm only going to be defined for this left-hand side, so where x is less than or equal to 0. Now, a typical parabola opening downward would go to this kind of like over 1, down 1 right here. However, we're stretching by 3, so instead of 1, we're going to go 3. So I'm actually going to have a coordinate down here. Or what you could think of is if I plug in x equals negative 1, that'll be negative 3 times positive 1. Negative 3 plus 2 is negative 1. So you could think of it by making a table as well. But in terms of graph transformations, that's what we have. A typical parabola, we'd have this kind of over 2 over 4. However, instead of this distance of 4, we're going 3 times that. So we'll have another 4, and then another 4 down at that negative 10. So what we have here is our parabola opening downwards like that with the stretch of 3. So that's how our graph transformations come in, is that we can make this sketch, we can make this graph without our calculator. Alright, so domain. What we're seeing is that domain of x stopping at 0, but we have everything to the left. Now for our range, the maximum value is positive 2, and then we can have everything below. So for the range, we'll have everything from negative infinity up to positive 2. Now, finding our formula. So what we're going to do is take our formula and we're going to switch x and y. So I'm going to have x equals 2 minus 3y squared, and I'm going to solve for y. So I'm going to subtract 2 from both sides, so I'll have x minus 2 equals negative 3y squared. I'm going to divide by 3, so that'll give me y squared equals x minus 2 over negative 3. And then what I'm going to do is take the square root of both sides. So this gives me y equals, and then technically plus or minus the square root of x minus 2 over negative 3. However, if I have plus or minus, if I graph that kind of radical function and I do plus or minus, that's going to give me something like this, which is not a function. And it wouldn't work as a reflection of our original graph there. So what I need to do is figure out, do I have the positive one or the negative one? So let's make a graph of our inverse function. So where I have the point 0, 2, I would have the point 2, 0. Where I have negative 1, we'll have that same coordinate there. And then negative 2, negative 10 means negative 10, negative 2. So my graph here looks like this. So that radical makes sense, because this looks like a radical function. Something we've done is we've had a few reflections, because if you remember, original radical function looks like this. So you can see is we've had a reflection over the x-axis. We've also had a reflection over the y-axis. So if we think about just those reflections and look back here, so here's my reflection across the y-axis, but to get that reflection across the x-axis, I need a negative in front of my function, just like we saw with the negative 3 in our parabola. So I need the negative symbol out there. Now, that takes a very strong understanding of reflections and negatives in our functions. So if none of that made sense, you can always use your graphing calculator, because we know what the general shape should be. So what we could do is go to our graphing calculator, plug in that square root function, so square root, and then what we have our numerator of x minus 2, and then denominator of negative 3. And what we can see is if it's positive out front, we're not getting the correct graph, not based on what we formed on our grid. But if I put a negative out front here, there it is. So you can use the graphing tool to help out to know which form of the function do you need. So with that, that just verifies that we need that negative out front. So this right here is our inverse function. In fact, I'm going to replace y there with f inverse of x. Stating the domain and range, I left way too much room here for that question because there isn't much work to do. We can just take the domain and range from our original function and switch them. So this will be from negative infinity to 2, which that should be a square bracket because we want to include that vertex. And then range will be negative infinity to 0. And then we can just verify that with the graph that we made down here. Domain, negative infinity up to 2, range, negative infinity up to 0. All right, so domain and range of our original function, and we can think about our graph transformations a little bit to get that graph going. Finding the formula by switching our variables and solving. And if you have that plus or minus, you just need to choose which one, either by looking at the graph or using Desmos to help out. Domain and range, just switching the original domain and range, or can look at the graph. And then here, sketching them on the same grid, and all I need to do is label which function's which, because just having them on the same grid is confusing. So there we have f of x, and here we have inverse of f of x. All right, so there's some graphs of our inverse functions.